Good morning, Form 3s. Welcome to lesson number 1B, which is a continuation of lesson number 1A. With me, Bivon Mose from Margmary Hills High School. Now, let's begin from what we were saying yesterday. Yesterday, we looked at what is a matrix, and we said that a matrix is a rectangular representation or arrangement of elements. For example, we looked at a matrix of, for example, we looked at a matrix like A, B, C, D, E, F. We said that these are elements. Element A, B, C, D, E, F are elements that make up a matrix. A, B, C, D, E, F are elements that make up this matrix. Therefore, we went further yesterday in our lesson number 1A to look at the order of a matrix. We categorize these matrices in terms of orders. We said that the horizontal arrangements, these horizontal arrangements, we were calling them rows. We were calling these rows. This row number 1, this row number 2, and this is row number 3. Also, we said that we can look at this matrix in terms of rows, which are the horizontal arrangement of numbers. Also, we can look at this matrix in terms of columns. This is our column number 1, which is the vertical arrangement of elements. This is column number 1, and this is column number 2. Therefore, students, we were able to deduce and state the order of any matrix by simply saying the number of rows followed by the number of columns that make up that matrix. For instance, in this matrix, we can see that we have how many rows? 1, 2, 3. So the order is 3 by how many columns? 1, 2. So this is a 3 by 2 matrix. That is from yesterday's lesson number 1A. Now let's move on to lesson number 1B, naming of elements that make up a matrix. These elements can be named. We can name these matrices, elements that make up a matrix, by simply stating the row, the number of the row followed by the column. For example, let's look at an example. Let's consider a matrix A, B, C, D, E, F. Let's name these elements respectively. Let's name all these elements A, B, C, D, E, F respectively. You can see that this is row number 1, this is row number 2, and this is row number 3. Also, remember we said that rows are horizontal while columns are vertical. This is column 1 and this is column 2. Therefore, this element A takes which position? It takes a position such that it is in row 1 and column 1. So we write that position as a subscript. So we write A is taking a position of row 1, column 1. We start by the row followed by the column. Remember, we said that it is R followed by C. R, C. So, which position is element A taking? It is in position row 1 and column 1. Remember, we write that one as a subscript. It is a subscript. And now, let's look at B. Let's look at element B. Element B it is in row 1 and column 2. So this is element 1, 2. We say element 1, 2 and not element 12. This is element 1, 1 and this is element 1, 2. We don't say element 11 or element 12 or such. Now, what about element number C? Element number C is it is in position of row 2, column 1. So this is element 2, 1. Element D is in row 2, column 2. Subsequently, this element E is in 3, 1 and this is 3, 2. Are we together, all students? Now, we have named the elements that are making up these matrices. This is how elements of various matrices are named. This is element 1, 1. We say element 1, 1, 1, 2, 1, 2, 1, 2, 2, 3, 1, and so on and so forth. Let's look at another example. Now we are trying to name A, B, C, D, E, F, G, H. Let's name that matrix very quickly. Now, how many rows can you see? Rows go horizontal while columns go vertical. Rows are horizontal and columns are vertical. So we have this is row number 1, this is row 1, this is row 2, this is column 1, column 2, column 3, and this is column 4. Now, let's name those elements. Remember, we start by row followed by column. Not the other way, not vice versa, It can never be vice versa. It is row followed by column. So element A is in position row 1, column 1. So element 1, 1. What about B? It is in row 1, column 2. This is 1, 3, and this is 1, 4. Row 1, column 4. What about element number D? Element D is in row 2, column 1. What about E? It is in row 2, column 2. This is 2, 3, and this is 2, 4, and so on and so forth. That is how we name the elements that make up a matrix. So whenever you see these numbers, they simply mean the first number shows the row, the second number will show the column that matrix belongs to. Let's move on. Now, let's move on to today's lesson now. Addition and subtraction of matrices. Now we want to start doing operations that can be conducted on a matrix. Operations such as addition, subtraction, and multiplication of matrices. Let's look at how we add and subtract matrices. There is a note here. This is what will guide us when we shall be adding and subtracting all matrices. Now, it reads, matrices can only be added or subtracted if and only if they are of the same order. Remember yesterday we talked about order of a matrix. You look at how do you know the order of a matrix? You state the number of rows that matrix has, followed by the number of columns. So, and the statement says we can only add a matrix to another matrix if and only if those matrices are of the same order. Now let's look at our first example. Example number 1. Given that, solve this example. Given that P is equal to 2, 5, okay. You cannot write them as close as such. 2, 5, 4, 0, 7, 3, and we have another matrix here. We have another matrix Q given by 1, 3, 8, 6, 2, 5. Find A, P plus Q, and number Roman 2, P minus Q. Now, look at those matrices. Now we are, the first one, we are supposed to add matrix P to matrix Q. Matrix P to matrix Q. You can see that. Let's first of all look at if this operation is possible. Is this operation possible? Remember we said that addition and subtraction is possible only if and only if these matrices are of the same order. Look at this. What is the order? This is 2 by 3. 2 rows, 3 columns. Also this one, it is 2 rows and 3 columns. Therefore, addition and subtraction is very, very much possible. Let's attempt the first one. We add these matrices: 2, 5, 4, 0, 7, 3. Add 2, 1, 3, 8, 6, 2, 5. What will be our answer? Now we add those elements that take up those positions to the element which take the same position on the other matrix. For example, this is element 1, 1. We add it to element 1, 1 of the other matrix. Element 1, 2 to element 1, 2. Element 1, 3 to element 1, 3. Element 2, 1 to 2, 1. 2, 2 to 2, 2. And 2, 3 to 2, 3, and so on. And it's very easy as such. Now let's start. This element to this element. Remember, we add or subtract elements that are of the same, in the same position. So 2, we shall add to 1. So 2 plus 1 is 3. 5 plus 3, 8. 4 plus 8 is 12. 0 plus 6, still 6. 7 plus 2, 9. And 3 plus 5, 8. So this is our answer. Remember to enclose your matrix in a bracket as such. Hope you have seen what we are doing. What we are simply saying is that you add or subtract those elements that are taking same positions. Element 1, 1 to element 1, 1. Element 1, 2 to element 1, 2. And so on and so forth. So 2 plus 1 is 3. 5 plus 3, 8. 4 plus 8, 12. 0 plus 6 is 6. 7 plus 2 is 9. And 3 plus 8 is 3 plus 5 is simply 8. So we add or subtract those numbers, those elements that are in the same position. Let's look at the second example where we were supposed to do P minus Q. P minus Q. But what was P? What was the matrix represented by P? It was 2, 5, 4, 0, 7, 3. We subtract matrix Q, which was 1, 3, 8, 6, 2, 5. So same. Remember we said that the key factor here, the underlying statement was that for us to add or subtract matrices, they must be of the same order. They must belong to the same order for us to be able to add or subtract them. If we look at these matrices, they are of the same order. We have 2 rows and 3 columns. Also this one, it has 2 rows and 3 columns. Therefore, subtraction is very, very possible. So we move on and say that this will be the same as, now we subtract elements of the same position. Element 1, 1 to element 1, 1. Element 5, 3, element 1, 2 to this one, this one to this one, this one to this one, and so on. So let's do it very, very quickly. 2 minus 1 is simply 1. 5 minus 3 is 2. 4 minus 8 is negative 4. 0 minus 6 is negative 6. 7 minus 2, 5. 3 minus 5 is negative 2. And that is our answer. That is our answer. We simply subtract those matrices that are that are occupying the same position. This one to this one, this one to this one, this one to that one. That's why we said that for us to be able to add or subtract, they must all belong to the same order. Hope we are together up to there. I hope we are together up to there. So let's look at yet another example. Our last example. Our last example of the day. I think we are done with those examples. Unless we can do one before we finish. Let's do one example. Let's do one example before we finish. I hope that you have understood. I'm getting these examples from KLB book 3 new edition. I'm getting all these examples from our KLB book 3. I think we are running out of time, and up to there we can call it a day. Now that we have known that how to add and subtract matrices, we have looked at the positioning. How do we know the position? This element 1 1, 1 2, 1 3, 2 1, and so on and so forth. And we have looked at how to add or subtract matrices. How to add or subtract matrices. Now let's do the last example. I think it's very important. Let's do this example that says that we are given that matrix A is 3 2 1 3 2 1 0 4 5 1 3 2, and we are given another matrix B. B is matrix 2 4 1 2 4 1 1 2 0 5 9 6, and we have our last matrix C is given by 8 0 2 8 0 2 1 3 5 and 2 1 6. We have this as our matrices, and you are told to do to find A minus B plus C. Find A minus B plus C. A minus B plus C. So this is what we are supposed to do as our example. We are supposed to do A minus B plus C. So it is matrix A, we subtract matrix B, and we add matrix C. So this operation is very possible because all the matrices belong to the same order. They belong to the same order. As you can see, this is a 3 by 3, it's a 3 by 3, and this is also a 3 by 3. Therefore, this matrix is very, very possible. This operation of addition and subtraction is very, 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 very possible. Therefore, we can do 3 2 1 3 2 1 0 4 5 1 3 2. This is matrix A minus matrix B of 2 4 1 1 2 0 5 9 6, and we add C 8 0 2 1 3 5 2 1 6. So remember what we said is that we add or subtract those elements that are in the same position. Element 1, 1 to element 1, 1 to element 1, 1. So 3 minus 2 is 1. 1 plus 8 is 9. So our element, that one will be 9. So we move on to this one. 2 minus 4. 2 minus 4 is negative 2. Negative 2 plus 0 will remain as negative 2. So 2, what about this one? Remember, it is